Okay, so in this example, we're doing the same thing. The question says draw the titration or show the titration of OCl minus, and again, of means that's what we start with in our flask. And then it says with HCl, which means we are adding HCl from the burette, okay? Now, the concentrations are the same, the volumes are the same, so the math is going to be the same. But as we move forward, we are going to change concentrations. Things are going to get a little different. But right now, I'm just focused on you understanding this process, okay? So first things first, we need to start with our initial pH. If we're starting with OCl minus, that means that that is all we have initially. We only have OCl minus. So because OCl minus is, well, actually, let me ask you, what is OCl minus? Is it an acid or is it a base? Cass. Okay, it's a base. And what kind of base is it? A strong base or a weak base? Bill. No, it's not a strong base. It's a weak base because it has a negative charge. It's an anion. The only strong base is OH. Now, we're gonna write OCl minus plus H2O because it partially ionizes because it's a weak base, and it's gonna give us HOCl and OH minus. Now, because this is making OH minus and it's a base, we need Kb. But you guys know by now, Kb is not easy. To find Kb, we need Kw, which we know, and Ka from my data booklet. Now, look in your data booklets right now. What is the Ka for OCl minus? Charlene. Yep, it is 4.0 times 10 to the negative 8. So my Kb is 2.5 times 10 to the negative 7, okay? So now that we have our reaction all set up, we're going to make, where did I put the end of this marker? Oh, there it is. We're gonna make our ice table. So, again, make your ice table. You're gonna put moles per liter up here. Ice table. Mr. Burnett is rolling his eyes. Love it. Okay, we start with no products as always. We are adding, as always, to the product side, which gives us X amount. Our initial concentration is 0.1. It's going down. I'm yelling timber. All right, here we go. We're getting off track. So now that we have our ice table and our Kb value, we want to write our equilibrium law. So Kb, which is 2.5 times 10 to the negative 7, is equal to product, so X times X squared over 0.10 minus X. Okay, now we want to get rid of that minus X, so we do everyone's favorite approximation. Okay, sucks. Kobe. I actually made it. Now, you're gonna take OCl minus, the initial concentration, divide by Kb. Show me in your calculator or Mr. Burnett that it's gonna be greater than 1,000. Let's do it. Okay, greater than 1,000. X goes away. You want to get X, you multiply both sides by 0.1 and then square root, just like always. Square root. And so our X value is going to be 1.581 ... times 10 to the negative 4 moles per liter. And not only is it X, it is also the concentration of hydroxide. Now, because we have OH minus, we can find our POH. And if you sub that in your calculator, you're going to get a POH of 3.80. Rounded right to 2 decimal places because the sigma for concentration. But we don't want POH. Our graph is pH. So we're going to subtract 14 and we're going to get 10.20. So what does that mean? That means we go to our lovely graph. You guys are probably just loving graphing right now. I just know it. And you're gonna go to 10.2 and you're gonna draw a dotted line. And at 10.2, you're gonna put a dot because that point exists. That is the pH of your OCl minus before you've added anything, okay? Now, what are you adding from the burette? What are we adding, Joanna? So we have a sample, right, of OCl minus in this flask. We have a burette of HCl, exactly. So what we're gonna do is we're gonna have our OCl minus. Again, we have way more OCl minus than OH, okay? So we have that, and eventually we're gonna add enough HCl out of the burette that it's going to react with and completely with OCl minus, okay? Now, you're probably thinking to yourself, hold up, Willie, why did you write H3O there? It's because HCl is a strong acid, which ionizes 100%. You're probably hating me saying that every single time, but you guys need to start making these connections, okay? So, single arrow means, exactly, molar coaster. So, concentration of OCl minus is 0.1 moles per liter. Volume is 25. Moles is C times V, which is 0.0025. Okay? Now, we're going to mole coaster that. And that's going to give us the same moles, shocker. Again, not always the same, but in these examples it is. The concentration is 0.1. So to find the volume N over C, you're going to get 25 milliliters. I understand, I skipped a step, but we know it by now. So we're going to take that 25. That is our equivalence point. This represents how much HCl we had to add to get to completely neutralize our weak base. And I'm going to mark that on my graph. Like so. Now, we had OCl. Hello, OCl. We had it. We added HCl. And then, bam, it neutralized. So all the OCl is gone, but we still have HCl, which means we're still adding HCl. So my final pH is only going to be based off of HCl. Okay, so that means that we have to look at what is the pH of HCl. Well, we know that HCl is a strong acid which ionizes, reacts with water, 100%. Again, super annoying that I have to say it every time, but I'm going to do it. We know that a proton transfer is going to happen to give us H3O plus and Cl minus. And we know the concentration of HCl is 0.1 divided by 1 times by 1, 0.1. Now, I know everyone is asking to themselves, do you have to show this every single time? Like on a diploma, guys, you're not going to show this, right? You're going to know it, but in order to know it and understand it, you have to start showing it, okay? So now that I have H3O, I can find my pH by doing negative log H3O plus. That's going to be negative log 0.1, which you guessed it because we've done it already. It's 1. So, go back to the graph. Go to 1 and graph your line. Perfect. Okay, the only thing that we're missing is the endpoint. To find the endpoint, we take the initial pH, the final pH, and we divide by 2. And again, this is not exact. This is an approximation. Now, before I do this calculation, I want you to think, what is this number going to be? Is it going to be 7, above 7, or below 7? So we have right now a weak acid, and we're adding a strong base. Hands up if you think it's going to be above 7. Local, put your hand down. Exactly. It's going to be below 7. So 10.2 minus plus 1 divided by 2. It's going to be 11.2 divided by 2, which is going to give us 5.7. 0.60. So I go over to my graph, find 5.6 on the y-axis, and go straight across. And what we see is my endpoint is, just as we predicted, below 7. So, last thing we got to do is connect our lines. This time we're starting up high. Again, pH doesn't change too much as we add base, but then all of a sudden shoots down and then stabilizes at 1. If you have any questions, you can go talk to Ms. Kopek about this. But guys, the next lesson, we're doing the exact same thing, except the acids are polyprotic and or the bases are polyprotic, which means they can do this twice. Now, don't worry, I'm not gonna make you do this twice. You do it once, and then we have an easy way to determine the second equivalence point and the second